Hi, good afternoon. This is Mr. Cassidy, and today we're going to do a review and a wrap up on Chapter 3, Lesson 2 on covering discrete and continuous graphs, domain, and range. Let's start with a little review. So we're going to start with a bit of review from 3.1. What is a function and what is not? So go ahead and start with A. Is this a function? You should have said no. Well, most of these lead to each input has one output. The last one we get is 3 here, and 3 repeats. That's the same input with a different output. So no, it's not a function. How about B? Is this a function? Well, no. We can test it with the vertical line test, and at this part of the graph, it's passing through 3 different times. That means for one input, there's 3 different outputs, so no, it's not a function. Okay, domain and range. What's the domain of the graph here in C? Okay, you should have chosen that x was equal to the set of numbers 0, 1, 2, and 3. Because those are the x values. Here is 0. That's the x value for each of the coordinates on the graph. What's the range here? We should have chosen that the range was y equals the set of numbers 2, 3, 4, and 5. Okay, and how about when we've got another graph here? What's the domain? Well, here it starts at 0, and so our x values are in between. Starting at 0 is less than or equal to x, is less than or equal to its maximum value, which is 5. X goes in between 0 and 5 on this graph. Right, and what's the range? Well, the lowest number is 2, the highest number is 7, so the y values are between 2 and 7, and we can write that as a compound inequality. 2 is our smallest, less than or equal to y is less than or equal to 7. All right, moving on. The next lesson we started to talk about linear and nonlinear graphs. So let's go ahead and review that. On A, is this a linear graph? You should have chosen yes. We can tell it's linear because it's a straight line. How about B? Is B linear? Well, no, it's not. Even though each of these sections have straight lines, because they are all one graph, this is not a linear graph. It changes direction. So that's how we can tell it's not linear. How about C? Is this linear? You might have said no, and I'm sorry, that was a bit of a trick question, but I want to push us to understand even those tricky ones. This one is linear. It's just that the dots aren't connected, but they are following the pattern that would follow a straight line. I think what most people get confused is linear is one question. A different question is discrete and continuous. So let's review those. On A, is that discrete or continuous? You should have said continuous. Why? Because the dots are connected. We have a line continuing in between them. Even though the line stops here, we still call it continuous. A continuous line can stop. It just means it is connected. It goes all the way in between. How about B? Is B continuous? Well, yes, it is continuous here. And how about C? Is C discrete or continuous? You should have said originally it was discrete. I know I connected the dots to make them clearly these are linear dots. It's just that they are discrete. So try not to get too confused by the two. Linear is asking us, is it following the direction of a line? That's what we mean by linear. Following a line without changing direction. whereas discrete and continuous have to do with continuity. Continuous graphs means simply that the dots are connected, and discrete graphs means the dots are separated. Feel free to take notes on that. I'm going to go ahead and move on. All right. Our next idea was linear and nonlinear equations. Now, to reiterate the lesson, just because I feel like this was a little rushed, we have a basic equation for all linear graphs, y equals mx plus b. And what that means is I can substitute in other numbers where m and b are, any other number, but I keep the letters y and x, and when I graph this, it'll be a linear graph. So if I did y equals 4x minus 7, what I've done is I've substituted 4 for m and minus 7 for b. And so they follow a linear graph no matter what. Let's try a few more. So y equals 1/2 x plus 3. That would still be linear because I've substituted a number for m and substituted a number for b. What's not linear is usually anything with an exponent or absolute value. So absolute value of x, that is nonlinear. And y equals, I don't know, x to the third power plus 1. This would be nonlinear because of that exponent there. So anytime you see absolute value or you see an exponent, just know those are going to be nonlinear no matter what. So go ahead and review. Let's review A. Is A linear or nonlinear? You should have chosen linear. How about B? You should have chosen nonlinear, because x is being squared there. How about C? C is linear. Now, if you missed this, the idea is B could also be that formula with y equals mx plus b. B could be a 0 here. So plus 0, we usually delete. So even though it's not there, it's still y equals mx plus b. It's just the b was 0. How about D? You might have missed this. This is nonlinear. And remember, this meets that rule. Anything with an exponent is nonlinear. And even though x is the exponent, it is nonlinear. Now, you might have mistaken this as an mx, but mx means a number being multiplied by x. Like on my examples to the right, 4x and 1/2 x, those are being multiplied by x. Here, x is the exponent. That's going to be nonlinear. Okay? How about E? E is very tricky. Think about if you could rearrange this equation. So this is a linear example. However, it's tricky because the 12 is on the wrong side. If we put plus 12 here and plus 12 here, those 12s would cancel out on the left and give us 1/2 x plus 12. That is a linear mx plus b format. All right, how about F? Y equals negative 10. This one also is tricky. This one is linear because m could be equal to 0. So what that would be is y equals 0x minus 10. And so mx plus b, we do have, now plus means sort of plus or minus. It could be a negative number, it could be a positive. But it still means it's going to fit the format because 0 is being multiplied by x, which cancels it out. So if you just see y equals a whole number. Now, somebody in one of my classes asked me, they sort of looked at all these and they said, are all the ones linear ones with like 1 and 2 step equations? I thought that was a good way of putting it. All of those can be basically thought of as 1 or 2 step equations. Like even y equals negative 10, that's like a solution there. All of those just look like 1 and 2 step equations on the right hand side. Okay, so that might help you think of the difference between linear and nonlinear equations. Our last idea from last week was linear and nonlinear on a table. Now, to do the table, just a quick recap, we're going to try to find the ratio or the rate of change of the line or the graph. And the ratio we're trying to find is the difference in y values divided by the difference in x values. So what we want to do is we look at the table and we try to calculate the difference in y and the difference in x. So I just do this on the outside of the table. I'm going to do A for you. The difference in y values here, 1 to 4, means it's adding 3. I'm just trying to find how much is it being added or subtracted to get to the next number. Well, that would be my numerator here. Plus 3 is my numerator. Okay, my denominator is the rate of change on the x values. 0 goes to 1 by adding 1. So I'm going to put over plus 1. That's my denominator. Now that is the fraction positive 3 over 1. So what I want to check is the next point the same ratio? Or does it simplify to the same ratio? So here, from 4 to 7, that again adds 3 points. And from 1 to 2 is plus 1. I make a ratio. Change in y goes on top, positive 3 over positive 1. And I check, are they equal? Yes, they are equal. So this is a linear table. So for B, I'm going to break this down for you. First, find the change in y values. Well, for the very first change in y values, it's the bottom of the table, which does make it a little confusing, and it is adding 2. Negative 3 plus 2 is negative 1. So that's going to be my numerator. Okay, find the corresponding denominator from the x-axis, or x values. You should have chosen that it is plus 1 here, so that means the denominator is plus 1. 2 over 1 is the ratio we're looking for. Go ahead and check the rest of them and make a decision. Is this linear or nonlinear? So you should have chosen linear. Each change is the same ratio. I have a plus 2 here and a plus 2 here. And on the denominator, it's plus 1, plus 1. This is a linear relationship because each of these ratios matches up. Okay, how about C? Go ahead and do all the steps for yourself and decide, is it linear or nonlinear? Now, I can't do this one in my head, so I have to do it out loud. Negative 2 to negative 10, how does that change? Well, negative 2 minus 8 takes me to negative 10. So that's going to be my numerator, negative 8. That's the difference in y over difference in x, negative 4 to negative 2. Well, that is adding 2. Okay? So the way I'm thinking of this, maybe to reiterate, is I'm sort of solving in my head negative 4 plus or minus blank, or x, question mark, equals negative 2. I'm trying to find how much is added or subtracted to get to the next point. Okay, so I got negative 8 over positive 2, which reduces to a negative 4 over 1. I want to check, does the next one follow that ratio? Negative 10 to negative 14, that's minus 4. And negative 2 to negative 1, that's plus 1, which is a negative 4 over positive 1. Those are the same ratio. Even though the numbers changed, notice the outside differences changed, it is the same ratio. So you should have come up with this was a linear table. How about D here? So I'm pretty sure this one's nonlinear, but let me go ahead and check. I've got a plus 2 on y and a plus 6. That ratio should be a 2 over 6. Both are positive, which simplifies to 1/3. Next one, plus 1 plus 3. Well, that's the same. That's a 1 over 3. That's the same ratio so far. Next one, plus 2 plus 6. Oh, I guess I gave you all linear equations here. This one's 2 over 6 as well, which simplifies to 1/3. So we've got, again, a linear relationship. Well, since I didn't give you a bad example, remember, basically, if you got one more row here, if we had one more row extending, and I don't know, the number was 10 and the number was 16, we would solve that and get plus 3 plus 1, and check it. 3 over 1 would not match the other ratios. So we would say, no, it's nonlinear if there were those bottom two. Okay? All right, carrying on. So today's little bit to explore that's new has to do with discrete and continuous. And we're going to look at a few word problems and try to understand them as sort of their linear ideas. So let's review. Things that are discrete basically can only be whole amounts in a word problem. For instance, buying tickets. If you go to a movie theater, if you're going to go to the movies, you can only buy a whole number of tickets. You can't just buy, I'd like a ticket and a half, please. You pretty much have to buy the number of tickets for the number of people going to the movies. I'm sure there are exceptions to that rule that you guys can come up with on your own, but most people buy the tickets for the movie they're going to see. Another example is a number of people. So if I had just a number of people in our classroom or online, that would be a discrete amount. I'm not going to count halves or partial amounts. Next, number of tires on a vehicle. That's going to be a discrete amount because it can only be a whole number. You can't have half a tire on a vehicle and still drive. Last, number of sugar packets. Those are discrete amounts because, you could dump out all the sugar packets on the table and count them up. If there's 16, that's a discrete amount. You aren't going to go in halves. Continuous ideas tend to have more to do with things that can be fractional or decimals, partial amounts between the whole. Think of it as a partial. For instance, time. Time runs in partial amounts, You could say every minute something's changing, but usually there's in-between time as well. Like if you're running a race, well, at 30 seconds, you're going to be further than you were at 15 seconds. There are partial amounts in time, and even milliseconds, or even nanoseconds. There are partial or fractional amounts between. Temperature is the same. There are partial or fractional amounts between every degree. If you're measuring the length of something, typically that would be partial amounts as well. If we were measuring the length of a table, you would probably get, 38.5 inches. And it's that partial amount that makes it continuous. Last, amount of sugar in coffee. If I was to, dump in a few spoonfuls and not really measure it carefully, then it's a continuous amount because it's going to be a very fractional amount. Whereas number of sugar packets would be whole amounts. So hopefully that helps you see the difference between discrete or continuous. So now we're going to put that to the test. We're going to work through a few word problems together. And basically our goal is to determine what is the domain given the word problem. Now I came up with this flowchart. I'd recommend, copy this in your notebook or go ahead and take a screenshot of it because these are all the thoughts that I go through as I'm doing these problems. So I'm going to walk you through a problem now. So here I've got a linear function, y equals 15.95x, which represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 4 tickets. So the first question they're asking us is find the domain of this function. Is the domain discrete or continuous? Explain. So to find the domain here, we need to really focus on x. And I ask myself, what is x here? X is the number of tickets in this word problem. And now I'm going to go through my flowchart here on the left and make some decisions. First, is it able to be in partial amounts or whole amounts? Well, X is a number of tickets. I think that's only whole amounts. I'm going to circle that. Whole amounts, discrete. Awesome. Next, can the x values be negative? We need to decide on the domain. Can the number of tickets, x is tickets here, can it be negative? Oh, no. No, it can't. So I'm going to circle no there. Can the x values be positive? Well, yes. And can the x be 0? Well, yes. They could buy 0 tickets. And in this case, is there a maximum? Well, in this case, it said the maximum number of tickets is 4. So now I'm going to try to write this all as a domain. And so I'm going to look at just the x-axis on the number line here and decide what is my domain. Well, I said x could not be negative, so it's not negative at all. I did say x could be 0, so I could have x value at 0. I said it was going to be discrete, so I'm not going to connect the dots here. And can the x values be positive? Yes, I'm going to start filling in dots that are discrete, positive numbers. And there was a maximum here of 4. So a customer can only buy 4. That is the domain right there. So is the domain discrete or continuous? It's discrete because you can only buy whole tickets. And the domain is, you can either say this a few ways. You can say x is, you could do it as the inequality and just write the word discrete, or only integers would mean the same thing. Or you can just list them. The domain of x is equal to 0, 1, 2, 3, 4. Now, the last idea that they ask us is to graph the function using its domain. That means that my x values are 0, 1, 2, and let's just leave it at that so that you get the idea. And what are the y values? Well, when x is 0, y is 0. You don't spend any money. When you buy 1 ticket, you buy $15.95 because that's how much each ticket costs. 2 tickets, that's going to be, let's see here, $31.90. And, it's a good thing we stopped at 2. I think that's the only one I could do in my head. So to graph this, I'm going to put it on an XY axis. Here's my X axis, here's my Y. X was tickets, and I'm only going to graph those 4 points in the domain. So here I'm going to put $15.95. Here I'm going to put $31.90. And 0 tickets, 1 ticket, 2 ticket. And so this is just going to be the series of dots. Notice that it is a linear graph because, and I'm going to stop it here at 4 because remember, you can't buy 5 tickets in this scenario. And we could calculate that, but I'm going to move us on. So, main idea of this whole slide, this is a big word problem. And you've probably been sitting there going, okay, can we try this out ourselves? And yes, it's time to try that out. The main point is I asked myself all these questions and I sort of turned that into a number line in my head to figure out domain. Okay? So now you try it. Here's our problem. We've got a 20-gallon bathtub draining at a rate of 2.5 gallons per minute. The number of gallons remaining, G, equals a function of the time, minutes. So we're going to start at 20 gallons and subtract 2.5 gallons every minute. I'm going to create this equation. Now we could turn this into a y equals mx plus b because that does help us. A negative 2.5 times m there, that's negative 2.5x plus 20 if I want to rearrange these. So does this equation look linear to you? Decide. You should have chosen yes. It is linear because we have a constant rate of change. All right, and we have it mx plus b. So find the domain of this function. Is the domain discrete or continuous? So I'm going to walk you through and you're going to pick the right answer each time. So first, is the x value, the x is the time in minutes. Remember, x is time in minutes. So decide for yourself, can that x value be in partial amounts or only in whole amounts? So you should have chosen partial amounts because you could do half a minute and you're going to be draining some more of that bathtub, even at half a minute or at 15 seconds or other partial amounts. Can the x values be negative? Well, no, you're not going to have x values that are negative because you're not going to start draining it before you start draining it. Can the x values be positive? Well, yes. And can the x be 0? Yes, that's right when you start draining it. Okay, so now let's start looking at our number line. I'm going to cross out negatives because we don't have those in this problem. We could start at 0. And probably at some point we're going to actually have a maximum value, but let's just go ahead and fill in, for now, the continuous line here. And go ahead and come up with your domain. And don't worry about the maximum for now. What is the domain of this problem, assuming it could drain forever? So you should have chosen that x can be greater than or equal to 0. All right. And is this function discrete or continuous? We already decided it was continuous. And to graph the function, well, we're going to start at something up here. Now, don't worry too much about the graphing. I'm just reviewing it with you. And later in this chapter, we really learn methods to graph easier. But here, if x was 0, y would start at 20 gallons because there's 20 there. And at 1 minute, we lose 2.5 gallons. So we're down to 17.5. 2 minutes. Again, you could just plug this number in for x. 2 goes in for x and do the math. You'd get 15 gallons and so on. So let's say I start here at 20, 15, 10, 5, and 0. Well, my x-axis is going to have to be here. And there's 1 minute, 2 minute, 3 minute, 4 minute, 5 minute. To graph this, we're going to go ahead and start the coordinate 0 here. At 1, notice I can't graph perfectly here, but 17.5 is just going to be in between 15 and 20. 2, it's here, and so on. In fact, if we continued this pattern, we should be able to see, well, looks like we run out. And let's connect the dots because it's continuous. Okay. All right, 2 final ones to really explore this idea of domain. We won't worry so much about the graphing. Okay, here we've got the linear function m equals 55 minus 8.5b. Okay, b is books and m is how much money you have. Looks like you start with $55 and then you subtract $8.5 or $8.50 for every book you buy. So why don't you run through the questions? First, decide, is this domain discrete or continuous? You should have chosen discrete. You're only going to buy, B is books, that's our X amount here. That's our part in the equation. You're only going to buy whole books, so this is going to be whole amounts only, discrete. Next, find the domain of this function. Well, we should say B is probably greater than or equal to 0, but only integers. And another way to do it would be to multiply 8.5 until you get up to 55 and then list how many books you could buy. 0, 1, 2, 3, 4, 5. I don't know, what is that? 6 and 7 maybe? I don't know. Probably somewhere around 6 you're going to run out of money. 6 times 8, 48. 6, yeah, probably these are the only amounts you could actually buy and actually get that. Awesome. So, and then we could graph it, but I'm going to go ahead and move on. Okay. Last idea. We have a pet grooming service here. They charge you $30 plus $5 for each extra service. You can read the problem here. X is standing for these extra services. Now, first off, you can look at the equation. Does this situation represent a linear function? you should have chosen yes. And yes, it does, because we've got a linear equation here, mx plus b. It's just flip-flopped. It could be y equals 5x plus 30. Now find the domain of the function. First, let's start by, is the function discrete or continuous? X stands for the extra services. Well, you should have chosen discrete, because you aren't going to buy half of an ear treatment for your dog. You're either getting the ear treatment or not. Paw treatment, same idea. Teeth brushing, same idea. You're not going to say, well, can I just get half of their teeth brushed for half the price? That's probably not going to fly. All right, and last, what's the domain? What's the domain of this? What are the x values that work in this problem? Well, x could, again, we're probably going to end up with x being equal to 0, 1, 2, 3. And in this case, we've got actually 5 possible treatments. So we're going to max out here at 5. That's our domain. All right, guys. Well, that covers it for word problems. I hope this gave you sort of a bit of an overview of how to decide when is the function discrete or continuous, because that's the main idea here. And some of the questions that I go through in my head when I'm trying to figure out how to graph a word problem and whether to connect the dots because it's continuous or graph them as dots because it's discrete. All right, I thank your minds and your hearts, and I wish you a good math afternoon.